Okay, let's have another lesson. Well, this is my sun in the universe, right? And we're talking about sun track rolling around in a little, in a little concave fracture. Now, what you might know if you're not a geologist is that if I crack this and make a little fracture here on the lip of my ceramic, I would get a conchoidal fracture, and it would just be a little one like that. You must have seen a broken plate. That's where we get our conchoidal fracture. It would be just, it might just be like a little, can you see that little bit there? No, it's not very good. Don't worry about it. If you've chipped the edge of a plate, you'll know about conchoidal fracture. Now let's move on, and that is supinate, and that's the shape, that little bit there, and those lines are the track. And now I'm going to confuse the hell out of everybody. I'm going to make an atom, and we're going to talk about, I'm going to question you. if I put these lemons in here and make this an atom, and then I've got electrons flying around the outside, and I've got protons and neutrons in there, then we just leave it there with a thought. This might just be the big question when we're talking about gravity. Is light a wave, or is it a particle? Does it behave like a wave, or does it behave like a particle? Light from the sun. So that's just going to go into atom and atomic energy, nuclear power, that sort of thing. So at the moment it's changed from the pocket that the sun sits in the middle of the universe, and now this has been conchoidal fracture, and now this is my atom, and this is the nucleus of the atom. And we're going to talk about the debate about waves or particles. Light. We're still talking about light. And we're still talking about gravity. Remember, John Mayer has put the two together, light and gravity. Now, I've made a little diagram here because we looked at Gabrielle in Kashmir riding a horse, and then we talked about how trees align themselves in the geomagnetic field in Kashmir at altitude over a shallow pan of water, and maybe fumey eject with minerals, because we know the Indian subcontinent is pushing into the Eurasian plate, and mountain building, there's probably pug there and fracturing and diking. It's not listed as a geothermal area to my knowledge. Right, I've drawn the trees in Kashmir on the top of a magnet which I've drawn. I tried to magnetize old magnets in my lab, but I never really managed to make them much stronger. But we did have an incredibly strong horseshoe magnet. So magnetism is actually a really strong force. And if you get a really good horseshoe magnet, your school might not have one. They can be so strong you can't pull a piece of metal off them. With the biggest guy you've got, they're really strong. Rightio. Now, we've got a Kashmiri tree here. They're long and skinny because you've got a evaporate float holding enough water in the atmosphere there to grow a very tall, skinny tree. So they look like that. They're quite unusual, and you won't find them like that anywhere else. It's a very unique place. But here's a bar magnet, and if you have a piece of plastic or clear film over the top and then put iron filings, like a light dust all over it, you get that pattern. And you've got a north end and a south end, and it goes north to south. So there would be arrows they go outward from the poles, and then they go from one pole to the other, and that gives you the force of attraction. So you would put an arrow. Oh, I haven't done that. Oh, can I get my lid off without my teeth? No, I put an arrow that way. Rightio, so you have a good idea about magnetic. These would be little bits of iron filing, and they would not be magnetised, but they'd sit in the field, and you'd see that the field was created, and little bits of iron will align themselves to invisible lines of force. It's quite remarkable. You don't see the lines of force until you put the iron filings on top of it. But that's how we think, you know, these trees are growing and aligning themselves, and holy, you know, what sort of pulsing are you getting? But of course, whenever you do this sort of thing, you're in a field where you are in the lab, and you can never divorce yourself or put yourself in a vacuum or without rhythms. Your own body makes rhythms. Okay, so let's think. What is our Earth like? Is it like, has our Earth got a magnetic field, and does it look like that? With, you know, and does the universe have a bottom and a top? do we have a bottom that we're like, this is the South Pole to us, and we ride on this water? Is this the top of the universe, and this is the bottom? People ask these questions. Is it like this? Do you think it is? I'll put the big G there on back to front. Or is it like this, wherever we've got venting out of our asthenosphere, like in Iceland, Kashmir, all the way along the orogeny area of the Himalaya, where it's pushing the subcontinent up, the Rockies and other volcanic areas and geothermal areas, New Zealand? Is it more like we've just got little bits of geomagnetism in isolated areas which are distributed according to plate tectonics and orogenies and thin areas of the crust and earth processes? So I've got that there just to help you. This is the way I see it, but you can think about that yourself.